today focusing on modern Android performance. I am Chris Assigbe, your host, and I am thrilled to kick off this new series designed to connect us more closely with our developer communities across Sub-Saharan Africa, the Middle East, North Africa, Turkey, and beyond. We have a packed session for you today. We will start with a few ecosystem updates, then move into a technical deep dive on performance, and wrap up with a dedicated Q&A session. Our goal with these office hours is to help you build and scale your apps more effectively on Android. While we won't be answering or reviewing individual code bases or specific account issues live, we are here to provide architecture advice, demonstrate, demonstrate essential debugging tools, and walk you through official escalation paths to help you navigate Android development and publishing on Play. We'll also try to answer your questions to the best of our abilities. Finally, we also hope to establish a direct line of communication with you, the developers, understand your journey, and address the challenges you may be facing. Today's specific theme is around building on constrained hardware. We know that in our regions, ensuring your apps run smoothly on devices with limited RAM or unstable connectivity is crucial for user retention. But before we dive into the technical talk, we want to provide you with a few ecosystem update within Q1 2026. First, in mid-April 2026, we introduced the new Android command line interface, CLI. It is designed to streamline development by acting as a high-speed API for AI coding agents. Please check it out. We are confident that it will speed up your dev processes. In addition to Android CLI, we also released the official Android skills. Head over to our official blog post for details. Next, we recently also released Gemma 4 under an open Apache 2.0 license. The release includes models like E2B and E4B, specifically optimized for mobile devices that require less than 1.5 gigabytes of memory and support native image, video, and audio processing. The Gemma 4 Edge models will serve as the foundation for the upcoming Gemini Nano. Next, Firebase recently introduced a unified API designed to seamlessly route AI requests between on-device Gemini Nano and cloud-based Gemini model. This hybrid approach is highly relevant for developers in regions with fluctuating network connectivity, like SSA, as it allows apps to balance latency, privacy, and infrastructure cost dynamically. Android Bench also launched in March 2026. It is a specialized benchmarking tool that ranks the performance of various LLMs on real-world Android development tasks, such as fixing GitHub issues or writing app logic. Finally, I want to highlight some upcoming community events in both of these regions. We have Build AI sessions happening in Zinder, Luanda, Constantine, and Agadir in Morocco, where I am streaming from today. These are fantastic opportunities to explore Gemini 4, and other Google AI offerings. Now, for our technical deep dive today, I am joined by Android GD Yves Kalume. Yves will be walking us through the three critical phases of modern app performance: inspecting, improving, and monitoring. He will demonstrate how to leverage tools like system tracing and macro benchmarks, excuse me, to ensure your apps are highly performant, even on hardware constrained devices. Eve, the floor is yours.
Hi, Chris. So, hello everyone. Thank you for joining us, and I'm really glad to be here with you. I am Yves. I'm an Android engineer at Monaco, and today I wanted to talk you to talk with you about Android performance. It's a really vast topic, and I'm really excited. So, let's jump right in. When we talk about performance, what we think of as the perfect app is the one which launches almost instantly. It feels smooth all the time, scrolling is fluid, no jank, and everything responds almost immediately. So it doesn't drain the user battery and doesn't use too much data. Also, it should be small to no use a lot of space on the user's phone. But the reality is totally different. In our market, what we deal the most with is slow and unstable internet connection, regions that are blocked by tools like Cloudflare, low-end device, and sometimes very old Android versions. And sometimes you can find devices that are only available in some specific regions. So the only way you can get them is to go to these regions. And most of the time, those devices have limited storage and cheap CPU, etc. And like everywhere, you will have user who will never update the app. So that means before even talking about all these sophisticated tools, we need by default to have a certain way of doing. So from the beginning, I can say during the development of your app. For example, something as simple as an unnoticed IO operation on the main thread on your device, you might not even feel it, but on low-end device, that can freeze the UI. So to protect yourself from that, during the development, you can use strict mode. It will warn you whenever you are doing a heavy operation on the main thread. R8 Optimizer can make your app smaller, improve the runtime performance, and more. So it's recommended now to use the ProGuard Android Optimize, which contains automatically generated optimization rules. And I really love this. For app that doesn't use R8 yet, this is for you. You can now optimize specific packages by using R8 with just package scope. So in your module level Gradle build, add the optimization block. Inside this block, use the package scope to list the specific packages you want to optimize. So right now, we can start with the Android X and Kotlin libraries because they are stable and built for R8 compatibility. And on low-end devices, CPU are very limited. So the system can kill your app very aggressively to free memory. That means your app can disappear at any time. So if you don't handle that properly, users will lose their progress, their input, and everything. So state restorations become critical. You can use APIs like save state handle. And with Jetpack Compose, you can have things like remember savable, remember serializable. And with Nav3, you also have some great APIs like nav backstack, and we also have some decorators for the nav display. And when users can now rely on connectivity, an offline first approach becomes very extremely valuable. So stay tuned because this is what we are going to cover in the upcoming office hours. And some companies go even further, especially those building app for remote areas or doing data collection, they use server-driven UI. So that their user won't have to update their app for some use cases. And I really think Remote Compose is going to make that even easier. So there's a lot you can do. You can, for example, use WebP images, you can leverage coroutines to make your app performant. But we can just go with our intuition. We need to measure and make sure that what you are trying to improve worth it. And at the end, we need to know that it has been improved. So we can split this in three phases. First, we need to inspect what we are trying to improve, and then we can start improving it. And at the end, we need to make sure that it has been improved. So we need to monitor how our app is behaving in production. And it's a loop. We need to optimize our app as long as it is alive. So let's see how we can inspect our app performance. Android provides us several tools we can use to inspect our app performance. But it's recommended to focus on one area at a time during inspection. There are many performance metrics, but the key one includes the app startup, how much fast your app can be opened and be used by your customers. The overall responsiveness, is your app smooth when users are navigating between screen scrolling? Also, is your app using too much battery or too much data on your user device? And also, it should not take too much space on your user's device. And also, any stable app should never crash. But yeah, we can cover all of them in this session. So, but let's say your app have some responsiveness issue. Let's see what we can do. But you can just start inspecting for a problem that you didn't notice. And it should be near the most real condition. That means you should inspect the release build of your application and you should do it on a real phone. Also, you should look at the system level because what is happening on your device may have an impact on your app performance. So, for example, you can see a jank or a drop frame visually just by using your app. Also, in the logcat, you can see tags like choreographer when you have more than 35 frames that are skipped, which means when you are at 90 FPS, it is around 333 milliseconds. And when it is more than 700 milliseconds, the OpenGL renderer will show you something like the very to show you that there is frozen frame. And when it is more than 5 seconds, we have the most famous application is not responding error. Now, after spotting the problem, we need to reproduce it. If we can do that, that means we can debug it. And for that, we can use tools like the Android profilers. But since we want to verify in the release mode, that's not possible by default. To make sure your build can be profiled, you need to add the profilable tag in your app manifest, and it's available since Android Q. The first step to debug your app performance is system tracing. It allows you to collect information on everything that is happening on your device at a certain time. So it helps you see what your app is doing and when, and you can see things that are taking longer than you might expect. You can run your application in release mode and then open the profiler in your Android Studio and attach it to your app. But this is my favorite feature right now. Let's say you are out, you are not on at your workstation, you can see and you notice a problem with your pro version of the app. You can go in the developer settings and enable the system tracing option. And the trace file will be saved on your device, and later you can analyze it or share it with your team. You can also use the Perfecto web tool, which use ADB. And after getting the trace, this is how the Perfecto trace viewer looks like. And if I have some responsiveness issue of my app, what I look first at is the frame timeline because it will show me what are the expected frames and what are the frames that are skipped. And then I can check the main thread to see what was going on when the junk happened. And then I can also check the renderer thread which is responsible for rendering my UI using the GPU. And if you look at this, we can see that we have the expected and the actual frame timelines. And we can see that frames have IDs. So we can see that this one take longer than expected, causing the other one to be, can say, dropped. But on the main thread, I can't really see what was happening. So if you want to have a lot of information, you can use the Android X tracing library. And then you can use the trace function from that library with a custom name as the parameter, and you can put everything you want inside this block. It also works with Jetpack Compose. So you can see something like this, and you now know which part of your code was causing the jank. And if you want to go much more deeper, you can use stack sampling. Stack helps you to understand which part of your code has been executed and why it was invoked. So we can also automate performance inspection using tools like macro benchmark. So we can test entire user flow, such as the startup, the scrolling, and navigating between screen. Setting macro benchmark is a pretty straightforward operation. So I'm going to share the link to the doc later. But let's see the result of how the test looks like. Frame durations is the amount of time a frame takes to be produced, and the frame overruns is the amount of time a given frame misses a deadline, and a positive number indicates a dropped frame and a visible jank. So this is available only from Android 12 and higher. We can fix the performance issue when we notice them. Maybe we just need to get off the main thread, or just make sure that you are caching the data and so on. But there are also some recommended way you can methods you can use to make sure that our app is performant for everyone. And one of them is baseline profile. So baseline profile is basically your way to telling the Android runtime which part of your code is very important. And they will then be optimized through ahead of time compilation so that the Android runtime will just execute them quickly. And it also can be set up like we do with macro benchmark, and it's very straightforward. But there are also some great configuration you can add to your Gradle build. For example, you can tell it to copy the generated files to your project source set. You can also tell it to generate baseline profile each time you run a build. And the profiler installer library ensure that the baseline profile are correctly integrated and compiled by using the Android runtime on the user's device. Now you can monitor your performance inside in order to make sure that the overall user experience is great. You can identify potential issue and optimize for those who haven't seen it, and so that your next user will never see this problem. You can monitor your Android vitals directly from the Google Play console. So you can see your app core vitals, because this one impacts the visibility of your app on the Google Play. You can also leverage the Firebase performance monitoring. So we can do it by adding the it plugin to your Gradle build, and out of the box, it will collect some white information like janky frames and so on. But if you want some more specific details, what you can do is to add it Gradle library. And what I like about it is this simple but powerful add trace information, add trace annotation. Sorry, and it will collect performance information about a specific function. But sometimes you can see performance issue like janky frames, but the problem, you don't know why it happened. And you just see something was slow, but you don't know which screen it was, what the user was doing, and how to reproduce it. And to solve that, you can use the jank state library. You can initialize it and enable the jank state library in your main activity on create method, and you can pass to it the jank listener callback, and you can even like send all the information to your log reporting queue, and you can later see that what the user was doing when the junk happened. Was the user scrolling a list? on which screen was it, and what data was shown. So you are the one to define the information you want to get. You can also run benchmarks in your CI pipeline, but you still need a real device. You can use services like Firebase Test Lab, and you must keep in mind that results aren't just pass or fail. So graphing results over time lets you monitor the change and observe noise in the measurement system. So if there's one thing to take away from all of this is that performance is not a single action, it's a continuous loop. And it's about keeping your app reliable to your users. So always start from their perspective. Also, tools don't fix the performance. You need to understand the problem you are trying to solve first. If you can find all the resources you want to get further on my Substack. And thanks. So I'll add back to you, Chris.
Thank you, Eve, for that insightful session. We'll now move into our Q&A. We received several great questions ahead of time regarding performance pitfalls, handling large leads without excessive recomposition, and strategies for reducing app startup time. Let's dive into those first. For the moderators, can we start with at the top of the questions? Bear with us for a second while we queue up these questions, and we'll go through them one by one. Thank you. Eve, I think this is for you.
Okay, when we optimize, if I can read it so that what optimize the app performance on low-end device, how do you balance between using coroutine flow in Kotlin versus more traditional approach in high frequency app update? So I'll say that using coroutine or flow is not the problem. So the issue comes when you are updating your UI with everything that comes through your flow. So maybe you can use tools like Dispatch to make sure that not everything is updating your UI. You only create recomposition when it's needed and when there is new data to be shown. And you can use tools like conflations, which will help you to have even more performance. Yeah.
Thanks, Eve. Next question, please. What are the biggest pitfalls, the biggest real world performance pitfalls when you are in large composed apps, and how do teams at Google structure recomposition and state to avoid them? I think there are a number of pitfalls really when you have a large composed apps, but the biggest of them all is usually unnecessary recomposition. Um, to avoid this, I think ensuring your UI states classes are stable. Avoid, for example, passing unstable objects like standard list or maps directly, and rather use a Kotlin immutable collections to wrap them. That tells the Kotlin compose that the list is going to be stable and not change unexpectedly. And for large lists using like something like lazy column, I think one method is to always use a key parameter. So Compose knows exactly which items actually change. Um, a clean architecture is used at companies like Google or Google Scale. It's but it's often adapted to each use cases for each app being built. I think while layering is good, mapping data to too many times in high frequency screens, for example, can cause memory churn. So it is common to intentionally bypass strict domain mapping, sometimes for simple data pass through to save on allocations. This is to say that we do recommend clean architecture, um, but you need to adapt it to your use case in order to have the best performance that you can for your app. Next questions. I think this is for you, Eve.
Okay, when developing application with Android architecture and Jasper Compose, what should we pay attention to in order to achieve a fluid and optimized result? So what I would say is, I think if you follow the Google recommendation, you will do more than half of the job. For example, making sure that your compose is stateless and leveraging tools like Room database to have an offline first architecture, and yeah, using tools like coroutines which help you simply easily manage like multi-thread operations without having like memory leaks and stuff like that. So yeah, you should follow the I recommend you to follow the modern Android architecture recommendation on the developer website.
Next questions. How do you recommend handling large ML models in production apps? Should we bundle them in APK, use dynamic delivery, or download them securely at runtime? This is a great question. Going back to Yves' talk, he mentioned how app size is critical, especially for user retention in markets like emerging markets and so on. And because of that, bundling a massive ML model directly into your base APK or AAB file is I would strongly recommend against it, but you do have a couple of options, right? First, our recommended approach is to use ML Kit, which comes with Gemini Nano, the latest Gemini, or all the Gemini Nano family, um, come pre-installed on some high-end devices. But also want to acknowledge that, especially in our markets that we're targeting now, SSA, Middle East, those markets, devices running in these markets don't are not always a highest end devices. And so if the ML kit route is not, and with Gemini Nano is not uh, suitable for your use case. I think play feature delivery or for on-demand modules could be a viable path. The Play Store will handle the heavy lifting for you and deliver the module securely only when the user actually navigates to that specific feature. Alternatively, also downloading the model securely at runtime from your own server is also perfectly fine. At least from a play perspective, downloading data files like a model at runtime is completely fine. So that's that's okay. With the shift towards clean architecture and Jetpack Compose, how do you recommend balancing performance and deep state management to avoid unnecessary recomposition in large lists? That's what we talked about earlier. I think um, um, making sure, like I talked about earlier, to use to fix unstable domain models with immutable collections is a good step forward. Um, I think also mapping on the background thread and not on the UR thread, and unnecessarily holding up the UR thread is a good practice for clean architecture as well. Um, so, for example, for all heavy state transformation or mapping that should happen in the view model using like dispatch.default, dispatch.default. The view model should expose a fully prepared, ready to eat like state flow of your UI state to the composable. And the UI should strictly be a dumb consumer of that state. So nothing should happen, no data transformation to happen on the UI side of things. Like I said also earlier, for things like lazy columns, using the key is really important in order to clear compose what exactly has changed in your list that you provided to it. This also helps you avoid unnecessary recomposition. And then really, another thing I can think of is really differing state reads for high frequency updates, right? So let's say if an item in the list relies on a rapidly changing state, for example, like animation or even like scroll position, passing that state directly on as a value will trigger recomposition all the way down the tree, right? So passing that state as lambda rather than the direct value, for example, can help defer the reading of that state um, uh, and avoid the unnecessary recompositions that we talked about. Next question.
Okay, great.
If this
I
is
think
you.
that is a great question. So I have integrated the baseline profile on my app, but so it seems like they are generated and bundled inside the app, but yeah, the new version, but you don't see the performance improvement. So I think the problem might be you should try to use the profile installer library, which makes sure that the Android's runtime use the baseline profile like on user device. So there's a library that you should try to use. Yeah, and I think it is a pretty straightforward issue and solution. Yeah.
Next question. Thanks, Eve. Wait. Um,
The pros and cons of reducing the app startup time. The only cons I can see is that you have a lot of users to deal with because they love your app. And yeah, if you improve the user experience, I don't see if there will be an issue or a cons for that. So maybe yeah, using the baseline profile can like increase the app size a little bit, but yeah, it's all in your advantage because you'll make your users happier, and you'll have the more reliable applications. Yeah.
Next question. This is for you again, Eve.
Okay, this is a great one because I remember the first time that I read the result from the macro benchmark test. It was kind of weird because you see P90, P50, P95. So these are just statistical concepts. its percentile. That means, so let's say I say P9 is 4. That means 90% of my results are lower than 4 and 10% is higher than 4. And if I say P50 is 8, for example, is 8 milliseconds, that means that 50% of my frames were drawn in less than 8 milliseconds, and 50% of the 50 other percent was drawn uh, in higher time than 8 milliseconds. So yeah, that is the meaning. It's just statistical concept that you can learn, and it's pretty simple to read. Yeah.
Next question. I'm currently working on an app with a large number of PDFs and looking into play asset delivery, but I'm finding the documentation a bit hard to follow for my use case. I completely understand your experience here. We do our best to keep our documentation up to date. But I think technically you can use asset delivery by putting your PDFs um, into an on-demand asset pack. But however, I think for a standard Android app here, I think what you looking for is more play feature delivery instead. Uh, Perhaps I'm wrong, but I think you can create an on-demand feature module that simply acts as a container for your PDF assets. This will integrate much more naturally with standard Android architecture, um, and by using something like the split install API. We don't have a code lab specifically for PDF and um, asset or feature delivery right now. But you can connect with the community and please reach out to us online, drop comments right into the chat. We'd love to connect with you and understand the use case a little bit more.
Oh, great. So, do I need to regenerate baseline profile every single minor release I do or bug fix? So you need to generate baseline profile if you make a change to one of your critical path, but you don't need to do it manually. You can just, as I said in my talk, there is some Gradle configuration you can use to tell it to generate for you the baseline profile on each build. So you won't have to do it manually. Yeah.
Thank you, Eve. Next questions. I think this is still for you, Eve.
Okay.
Between the Android Studio profilers and Perfecto, when should I reach for one over the other?
Yeah. So first, I think like the Android Studio Profiler is much more focused on your app, and Perfecto is like uh, at the system level. But yeah, both of them, you can use both of them, but with Perfecto, I feel like there's a higher learning curve. So maybe if you are starting right now to do system tracing and performance analysis, I will recommend you to start with the Android profiler. And also, yeah, try to learn Perfecto on the side, but it will take you much more effort than starting directly with the Android profilers. Yeah.
Next question. I think this is also for you, Eve. You talked about
Yeah.
using WebMP to reduce app size. Are there scenarios where we should avoid WebMP,
Yeah, yeah,
WebP, and stick to PNGs and or SVGs?
yeah. The first scenario is for very small icons. So you can just use vector drawables or yeah, SVGs. And if you are doing very aggressive compressions, so with WebP you can lose a lot of quality. So maybe you should stick with PNG, but you can also use lossless compression with your WebP. It all depends about your use case. But yeah, when you can just use the WebP to reduce the size of your app.
Awesome. Thank you. Next question. How much does the choice of architecture like MVM, MVVM, and MVI actually impact the UI performance? I think this is a perennial questions, especially since switching over to Compose. I think our recommended, first of all, our let me acknowledge this a brilliant question. The really short answer is it's not so much in the choice of the architecture rather than in the best practices that you use when building the app. Um, for example, we talked about how to handle lazy columns before. The principle still applies whether you're using model view, view models, and or MVI. Um, the recommended approach is from Google is obviously MVVM, but you cannot go wrong so as long as you stick to the fundamentals and use the best practices and avoid things like unnecessarily recomposing your UI or passing unstable state to the UI, or even doing operations, heavy IO network operations on your main thread and so on. So I think really those fundamentals matter more than the architecture choice. That being said, we believe in MVVM architectures. Next questions. This is a great question. Emulators allow you to really test quickly without having to use um, actual hardware. But nothing beats your app actually running on the in productions on actual hardware, especially in regions like SSA and the type of devices we see in that kind of region, or in the MENAT region. Low end or hardware constrained Android devices. Um, you don't you will have a better idea of how your app performs in the fleet. But we do highly recommend that we also recognize that you don't always have access to all of the variety of devices in the Android ecosystem. We love the Android ecosystem because it's diverse, it has a ton of devices, but it also introduces this challenge of testing on the actual devices. And so I think the I don't have a great answer here because the emulator is great. It helps you quickly test your app, especially if you don't have physical hardware to test. But especially in the case of hardware constrained devices, nothing beats your app actually running on them and testing on them. Next question.
aggressive resource shrinking with poor quality, and it sometimes breaks my app. Yeah, because it removes things via reflection. So, yeah, how do I balance upsize with stability? That's why I love the new optimization and package scope. So if you want, yeah, we know that R8 and ProCodes really misbehave when it comes to code that use reflection a lot, but you can try to optimize now specific packages. So if you have some part of your code in which you are using in which you are not using reflections, and you are sure that there won't be any issue, you can try just to optimize that part just by adding the optimization block in your Gradle build and by specifying this package. And you can start, as I said, you can start with official and more stable libraries like the Kotlin extension libraries and the Android X. And yeah, you can use also all the libraries that you know that can support R8. You can put them there, and yeah, just and also you can leverage keep rules. So to keep your code, the code that is using reflection from being removed. Yeah, I think you have a lot of options.
Next question. Is KMP now similar to CMP? Um, not quite, right? So let's explain both of these concepts. KMP, Kotlin multi-platform, is uh, for your sharing business logic between different clients. So you could share that business logic, for example, between a native Android app built in Jetpack Compose and a native iOS app built in SwiftUI. CMP, on the other hand, is Compose multi-platform that allows you to use Jetpack Compose to build the UI layer entirely for client mobile clients, Android, iOS, or even desktop and web. And so if you nowadays, I believe you create a CMP project, it comes with KMP right away to allow you to easily share the business logic as well. However, you can use one without. You can use CMP and have separated business logics. Recommend against it, especially if the business logic is not that different, which for the most part isn't really. And so, but officially, Android supports KMP in order for you to build a really great native Android app and share your business logic with other clients on the other side. Next question. I stopped my work because of the war, but now I want to go back to Android programming, and I have many inquiries about update development that took place, returns, and other inquiry. First, I want to acknowledge the difficult situation you're in. Returning to normalcy before war is never an easy things, but the Android community is really happy to have you back. And to answer your question directly, um, I'm not sure how long you've been off since the question doesn't specify how long you've been out out of development, but the industry has changed a lot, as you may have noticed in the past couple of years. First, Android has matured as a platform and continue to grow into ever expanding screen sizes, devices, and so on. We have large screens now. We have XR. and so on. So the ecosystem is expanding in a multitude of ways. So you will find yourself in an ever so evolving situation. I would recommend really looking into the new platforms that are built. Adaptive now is our recommended way of looking at apps from the ground up. So if you build an app from the ground up, make sure that it's adaptive for all screen sizes and so on. But even in the development process itself, things have changed quite a bit with AI assisted development now, right? We have built into Android Studio, Gemini and Android Studio to help you code faster, move faster, and build bigger and better things, right? So I will also highly encourage you to look into agent assisted development. Look at our Android CLI that I talked about earlier. Look into Gemini and Android Studio. We have bring your own model in Gemini and Android Studio for whichever model you prefer to work with, and so on. Hopefully, those help you get back to current as soon as possible. Thank you. What is the truth about modify order? Some articles say they apply from top to bottom. Moderators, can we have the questions back up? Yeah. From top to bottom, some the opposite. How to predict what I'm going to build before writing the UI? This is a this is a great question. First, I think the first thing to say is um, modifiers actually apply sequentially. Um, the reason articles seem to contradict each other is because of how top to bottom order actually affects the UI. The best mental model to predict what you're building is to think of every single modifier as wrapping the modifier below it, like sort of a layers of box you put in a box in a box in a box in a box, right? Um, and that's how you should think about it. For example, if we take a random one like modifier dot padding that has 16 dp, then dot background color the red. Because of the padding, because the padding is first, dust on top, compose will create an invisible box of 16 dp padding on the outside. Then it will step into that padding to draw the background, which in this case we'll say is red. So the result for that instance will be the red background does not cover the padding area because we apply the padding first and then we draw the background. Let's take the opposite one. Let's say it's modified dot background and then color the red and then padding 16 dp. In this case, the background is drawn first. Then the padding is applied, which will result in a red background that covers the padding area. So the padding area will also be red. We have a great article actually going in depth about um, uh, modifier order on developer.android.com. And my colleague Yolanda also had a series of videos on our YouTube channel diving specifically in these topics. Please check them out.
how to have
Eve, do you want to take this one?
yeah
How to
yeah
have a
so
smoothest navigation between screens.
yeah, I think there are a few things you can do. So the first one is if you have like you feel like your navigation is not that smooth, maybe you are creating some recompositions. So you can use the layout inspector to see what is happening when you're navigating. And so of course you can't get rid of all the recompositions. And the second thing I've seen a lot is the way people are loading initial data on a screen. So if you are navigating to from one screen to another one, you have to make sure that your target screen is loading data correctly. So you are not freezing the main threads. You need to leverage coroutines, and maybe sometimes you don't need to get again the data from the network. So are you getting the data from the local cache and so on? So the two things or three things I can tell you to focus on is are you how you are dealing with compositions, also how you are loading initial data, and then you can try to leverage baseline profile if you feel like you have done all the things. So, yeah, but you need to inspect first in order to know what is causing uh, your navigation to be janky. Yeah.
Um, to add to Eve's questions there also, I will highly recommend that you also look into Nav3. It allows you more controls over navigation and what you can do. So please check out Nav3 and our samples on GitHub to see how you can use Nav3 and best practices. And then for our last question today, um, how how do I test my Compose app in different screen sizes and foldables? That is a great question, given how adaptive is essential nowadays, especially with Android 17. Um, Especially in Android 17. So uh, one second here, real quick. Yeah. Great. For testing on foldables, we do expose the posture, foldable posture, and we do have a library like window size classes that allow you to get the size of the window available to the user in order um, to display the corresponding UI for that specific screen. You can get the device posture, such as if a device is in what we call tabletop mode, to get hinges. We also have test harness that that allows you to test and resize composables based on the screen that's available to the user. So as you may know, we have compact, medium, expanded. There is large and extra large sizes now, and the recommended way to test for is to use a remember a test harness to do so. Do we have any other questions? We can do. Okay, we do have one last questions coming in. What will be the future of Android developers? Where should we concentrate? I think we all facing this existential question as developers. It's not just for Android developers. I would not presume to predict the future for Android developers. I think if you ask me, and personally, is what I'm trying to do is to control what I can control, which is just get with the time that we're in, learn all of these new tools that allows me to be more productive, understand the AI landscape, play with all of these tools, and understanding where I can use this one versus the other, and then just be up to date with the tooling and all the new techniques that are coming. Is really all we can do. If I tell you what the future reserve for any of us, I'll be lying to you. So that would be the best answer I can give you. So thank you all for all those great questions. We have reached the end of our stream today. And I want to thank you all for joining us for this hour-long chat. Um, Remember that performance isn't just a one-time fix thing. It's a journey of continuous monitoring and improvement. We hope that today's session gave you the tools to start that journey a little bit more effectively. But before you go, please take a moment to fill out our feedback form. Your inputs will help us decide what topics to cover next, how to really make these sessions better for you. So please take a moment and give us some feedback. And I want to give a big thank you to Yves Kalume for sharing his expertise, and to all of you for joining us and building incredible things for Android. Please subscribe to our developer channel to stay up to date, and we'll see you in 2 weeks. Thank you very much.